Great. Let me also start the recording. Okay, so we have a replication factor of 2. Good, good. All right. All right, so again, do you have any questions for me before we start the discussion? No questions? Any questions related to HDFS? Okay. Also, today we are going to start again with the architecture of yarn, because as some of you had mentioned earlier that it was not clear in the previous session. So we will start from the discussion of yarn. Okay. Do you have any questions before that? Okay. A question from Amultan, that where does name node reside? Sorry, where the resource manager resides, is it on the name node? Not necessarily. It can reside anywhere. Okay, it can reside anywhere, just that resource manager's configuration would know where is name node, meaning resource manager would know where is name node, so that when a locality constraint, or when somebody says to resource manager that please execute my program near a particular file, in that case, resource manager would talk to name node to find out where is that file located. So it can be anywhere, it's your choice, just that it needs to know where is name node. Okay? Does it make sense to you, Amrita? Okay. A question from Kulveer. Can you please show one example of XML parsing with Hive? Yes. Okay. Yes. In case you want to go ahead and try the. Okay. Actually, do one thing. Drop me a separate mail, or maybe you leave this question on the forum. I would answer it there. Okay. Because it's little of the future. Okay. Good. Any other questions at this point? Okay. All right. Any other questions at this point? All right. All right. So let's start from where we left. Okay. So we were talking about, in the last discussion, we were talking about the architecture of yarn. All right. So yarn is composed of a resource manager. Resource manager is the customer interfacing entity, meaning the first interaction of the user happens with resource manager. So resource manager is kind of interface for every foreign entity. The easiest way to look at it is the client is kind of an entrepreneur or the industrialist, and a resource manager is kind of a president of a country. And then there are various states. On the manager of every state is node manager, or we can take an analogy with a chief minister of every state. These are the state head of the states. These are the three. These three entities are head of states. So whenever a client comes to resource manager that, hey, I need to get some work done, resource manager talks to individual node managers and negotiates with these node managers for the resources which client has asked. And then accordingly, whichever node manager is free asks that node manager to create a container. Okay, so the resource manager would ask node manager to create a container for the client. Now, there could be multiple cases. One, client says that, client tells upfront that, hey, I need 5 containers. Or client says, right now, you let my app master run, and app master would decide how many containers more we want. Okay? So the first step into the system is app master. App master is like regional office of a company. Okay? It's like that. So is the architecture clear? So client came to the resource manager asking for resources. Resource manager talked to various node managers. And then these node managers allocated containers for the client. And then container started executing their work inside that. Now, so the client, when they got the access to the container, okay, so okay, let me put it this way. Client wanted to get some work done, and they came to resource manager. Resource manager talked to the node manager. Whichever node manager was free, that when node manager created a container. Container is kind of a place, kind of a virtual machine, kind of a shell, kind of a guest house where the client can come and run their app master. So app master is the first entry point. So what does client want to do? Client always want to run an app master. And that app master can create more instances of the program. Okay? So for MapReduce, there will be MapReduce app master. And for Spark and others, there will be Spark Spark App Master, and so on. Does it make sense to you? Any questions about this? Yeah? No questions? All right. Now, the question is what? So here we talked about the first thing which app client wants is an instance of app master. This is app master, APP, meaning application master. Every application is like headquarter of a company. Say Microsoft came to India, they wanted a head office somewhere. So they went to Hyderabad and they created the head office there. It, let's say this is Delhi and this is Bangalore. So these are the various regional, various resources or various places available where the work could be done. Mapmaster is kind of head office, or you can say app master further decides what is it that a client wants to get done. If it's a MapReduce app master, the this app master would decide, would request first, this app master would request the containers for running mappers, and then it will again request containers to run reducers. Okay, that's how the magic begins. So the app master contains the core logic of every computational framework, whether it's Spark App Master, Application Master, or whether it's a MapReduce Application Master. The Application Master contains the core logistics, contains the core logic for the logistics of the whole framework. Because it's the first instance, it's like loading of a program into the memory. In a similar way, client loads this particular component on one of the node managers, and it starts running and performing the activity. Does it make sense to you, Ella? Yes. So the app master is talking to the containers in different nodes. Okay. So afterwards, after Microsoft comes to India to get their work done, they created their office in Hyderabad. They also opened a branch office in somewhere in Delhi, and so on. It's like that. So similarly here, let's say it's a MapReduce application master. It is going to ask resource manager again that, hey, I need 20 containers for running mappers or for running other logic. Then resource manager has to provide those number of containers to application master. Okay. A question from Ella is application master or app master a daemon that runs, or is it Java code? It's basically a Java code. It runs. So a very important bit about application master. Application master could be ever running process which keeps on running forever. Or it could be per user, or it could be per application, per session or per user. Okay, so either it could be as and when user wanted, or it could be for the whole session. They could create a long running process, or it could be that we could create an application master which could run forever. Okay, do I make sense, Prem and Ella and others? Did I make it clear? How does it work? Prem's question is, there may be many containers. Yes. On every node, there could be multiple containers. And in the whole cluster, there could be many containers. Containers get created and destroyed. A question from Ashwin. And let me also note down a question from Prem. Question is, I'm just trying to see how to avoid line breaking. Okay, so question is, After the work is completed, even though the app master will be, yes, I think I missed your question. So there may be many containers. First question, yes. It depends on how many you want. And then Ashwin's question, I think I missed Ashwin. Am I reading it wrong? After the work completed, even though the app master will be in the nodes. Okay, question is, I think the way I'm understanding the question from Ashwin is that after the work is completed, will it keep running even though the even though the work is done? Will it keep on running or will it stop? Is that your question, Ashwin? It all depends on what kind of application master you have demanded. Did you ask? Did the client ask for ever running container, or did it ask for only session wide? Okay. A question from Yogesh. Suppose task 1 to get executed need 20 containers, and following task 2 will need only 10 containers. Does the rest of 10 containers are closed or killed? Suppose task 1 to get executed need 20 containers, and following task 2 will need only 10 containers. Okay. Yes. So the container is like a process. It is actually a Java process. So it gets run, and once it's done, it's just destroyed. It's not handed over to another application master or another client. Okay? Because container, just like any program would have its memory would contain the data related to process, and therefore it is essential to remove container from the memory and then destroy it. Just like the way you have a web server, it creates many processes for every client's need. Similarly, a container gets created and destroyed when the work is finished. Do I make sense to you? Very good question, by the way. Yogesh and Ashwin. All right. All right. Good. Any more doubts here? So the client asks resource manager that, hey, can you create an application master for us? And here is the jar file. If you run this jar, it will start my application master process. So this resource manager negotiated with node managers and got one node which could create a container of the size which client has requested. Okay, so client can give many specifications to resource manager. Client could say that, can you run the application master? Okay, can you run my code on the machine which is very closer to this file, or all the machines which is very closer to this file? Or client could also tell resource manager that, can you give me the containers? Can you give me the containers which are located near the file? Second thing which client can ask resource manager is, can you provide me the access to can you provide me the access to the containers of the memory of, say, 2 GB, 1 GB, 100 MB, 200 MB, and so on. Or it could also ask for things like, can you keep my app master running forever? Unless I tell you explicitly to stop, keep it running. Okay, so those kind of demands the client can create. Like, for example, here. So the resource request from a client could include number of containers. How many containers do a client want? How much memory each container needs? And how many CPU cores does it require? And locality constraint, as in run it near a particular file. Okay, give me all the containers which are located near a particular file. That is locality constraints. Okay, and this resource request could be upfront or as you go. As you go means that first let my app master run. When the app master would run, it will again ask for certain requests, and it will keep on asking from time to time for various kinds of containers. Okay, so that's as you go. That's as you go. All right. So, and the application lifespan, which Ila was asking, the answer to that is it could vary dramatically. Lifespan is categorized into three categories. Okay. The simplest case is when you run a job, it gets over, the work gets done. And all the containers, all the application masters are destroyed. Okay, that's the simplest and most common use case. And mostly, this is the case which we would do. This is MapReduce. Now, second one is one application per session. It's like you open a session and you keep on running for some time unless you exit from it. The answer is Spark. You will see that once you start Spark, it will keep interacting with you. It's REPL, read, evaluate, and process loop. Okay, it keeps running forever, just like a command prompt. It keeps running again and again, running continuously unless you exit. Okay, so that's one application per workflow or user session. That's second kind of lifespan of a container. Third is long running, or you can say forever running. Okay, these are always on kind of processes. That's the third kind of process. Okay, so this we have discussed. Application client comes in, submits the application for resources to the yarn, which is, submits the yarn application. This yarn application contains few things. One, specification of the resources wanted. Second, what is it that application master would run? And then resource manager will allocate container and run the application master. Now this application master would start talking again to the resource manager. Again, you see, okay, this allocates more resources and then starts creating the various other containers. Okay, so this chain of process keeps on going, keeps on asking more and more resources, and keep on getting its work done. All right, there are quite a few questions. This one I'll let you take now. All right. A question from Ashwin is, can we relate this concept to multithreading? Yes, you can say multithreading. Each thread has its memory. Each thread is running its own work. So each thread is kind of isolated in the container, unless there is a communication between two threads. A question from Yogesh. So a single node may contain many containers, yes. And max containers is configurable. You must check it in the Ambari. Okay. Now Kulveer's question is, how many node managers can we have? Some node managers can have app master and some dot. Okay, so it's up to you. Generally, all the machines which you want to dedicate for computation, you install node managers on those machines. Okay, so the quick answer is you can have as many node managers as you want. Okay, generally all the machines which you want to dedicate for computation, you should install node manager on all those machines. Okay, so that's it. Next question is, some node managers have app masters, some don't. Yes, that's right. The question is, how does resource manager communicate with node managers? How does resource manager communicate with node managers? Over TCP/IP. Okay, basically it's a SSH call. All right. Good. Now, okay, the question is, what is TCP/IP? The way we communicate to a web server, that's a TCP/IP protocol. Okay, and so the resource manager and node manager talk over the network, and when they talk, they basically talk over a protocol called TCP/IP, and that's how it works. Uh, do I make sense, Priya? Okay, good. Next is, for single task, is there a possibility of having two or more containers on the same node? For a single task, is there a possibility of having two or more containers on the same node? Yes, they can. They can have two or more containers on the same node. Let me think. So for a single, okay, not single task, I'll say single resource request. Let me think. So for a single resource request, is there a possibility of having two or more containers on same node? Okay, that's a difficult question. Um, all right. So uh, okay, so I'll keep it this way. So as per what I understand so far, it does not make much sense to run two containers for a single resource request or single yarn request on the same node, because because whatever two containers could do on the same node, your single container could also do the same thing by requesting for a bigger memory and by forking the by creating threads, because your your Java code, which is inside the container, can create threads, right? Therefore, therefore, it should not locate more than one container or one application on the same node. Okay, so as per my understanding, No, but let me put it in a to-do. Okay, to confirm, to confirm. Okay, let me confirm this and then I'll be done. All right. Because since the request could contain multiple CPU, that means a container could access multiple CPUs and therefore it can do the multithreading in itself. So most likely for one task, there will be only one container on one node. Okay, so that's my reasoning behind it. Okay, a question from PFM. Would Okay, this is an interesting question. Let me go through it. Would using Flume be an instance where you would keep AppMaster running for long periods? Yes, could be. Okay, but I'm not sure if maybe, yeah, this is an interesting perspective. Yes, because Flume agent keeps running on various nodes, and they keep on pumping the data. So although, as per my understanding, Flume agents do not run inside the containers, but theoretically, it could be. Okay? Generally, Flume agents do not run inside the yarn. Because those machines which are pumping data, do not uh, do not have Hadoop installed on them, and they are not mostly part of the yarn framework. So these clients, the Flume basically has a client. There is no server for Flume. Okay. The Flume client itself is a process which runs and accepts traffic from the local machine. So generally we install Flume agent all across the cluster, whether that cluster is Hadoop cluster or something else. So generally we run Flume agent on the web server where we are running on the websites and keep on pumping the data from everywhere. Okay. All right. So sometimes we want to create our own yarn application. The way, let's say you come up with an idea which is more appealing than MapReduce and more appealing than Spark, and you say that I want to create my own system. In that case, you can create easily. And the way you should do is, first, you should try to use existing frameworks. First, you decide whether it's really, really needed to create a new framework. Second, if that's not the case, in case you are not able to utilize Spark or MapReduce in your cases, in case you want batch processing, you go with MapReduce. In case you want instant feedback, you use Spark. Okay. Second, you could try, if that doesn't work for you, the first case does not work for you, you could try to utilize tools to build jobs. Okay. These kind of tools are already available, like Apache Slider. Okay. It runs existing distributed applications such as Apache. Okay. So Slider is a framework. You could utilize this kind of a framework of tools in order to build distributed jobs. Okay. Third is, if in case Slider and Twill does not make you happy and is not solving your problem, in that case you could build from scratch, but remember, it's going to be complex. The easier way to start is you go with Yarn's project example. They will give Yarn's project bundled example called distributed shell. Okay, this is called distributed shell. So you could check out the code and then try to see how is the distributed shell working, and accordingly you could also plan your application. Okay, makes sense to you? All right. So how many of you were able to interact with CloudXApp? Okay. First question is, were you able to create a folder on HDFS? Upload some file. So I'll just put it this way. Were you able to create an HDFS folder? Okay. Upload some files in that. Okay. Were you able to use Hadoop FS, copy from local? Okay. Okay. So only Yogesh is answering. What about others? Okay. Okay. So Lokesh is saying that is not able to upload a file. Okay. A quick suggestion to all of you, in case you are facing a problem. Okay, let me. Okay. I think I'll just go to cloudxlab.com. That will be easier for me. Okay. A common question is, could not upload Hugh's file, which is around 0.6 GB. Okay, so actually we have put a small restriction of 500 MB. Okay, we will try to remove that kind of a restriction. Okay, the workaround is that you go to Hue. Instead of directly going to Hue, you go to Hue 8888. Okay, you go to Hue 8888. All right. So I'll just copy paste this link. Then those problems should disappear. When you try to upload a file and you're getting the error about uploading, you could try going to Hadoop d.cloudxlab.com and then this, okay, instead of directly. Because this, when you say this, it's talking to Nginx, which is redirecting to Hue, and then, yeah, so this way. Okay, good. So Ashwin and Yogesh and Yimang have done. All right. So yes, just give me a second and close. Oh, sorry. I was again muted. So yes, so you go to navigator.com/my courses and then open Hue and upload a file. Okay. Open Hue and upload a file. When you open Hue, it will ask for login password, enter the login password, and then upload a file, and then go to console, try downloading the same file using Hadoop fs minus copy to local. Okay. In the meantime, when you download the same file, try going through other commands of Hadoop fs. Okay. I'll write the detailed documentation maybe this week. Okay. But in the meantime, if you face any difficulties, okay, any difficulties in understanding, okay, any difficulties at any point of time, feel free to feel free to schedule a 30 minutes tutorial session with us. Okay, just suggest three different time slots to us. Three different time slots. Okay, this suggests three different time slots and email to support at no ticket. All right. Okay. A question from Kulbir. How shall we specify the file path using copy from local? So the next argument, Hadoop fs minus copy from local, the next argument afterwards would be the file name. Try just typing Hadoop fs minus copy from local. It will tell you, it will give you the suggestions, it will give you the manual. Okay, try going through that. Okay, if you get stuck at any point, feel free to drop us an email at support@nobigdata. And if you want to go through, one-on-one, you want to, do the lab one-on-one, I would be happy to help you. Just suggest us 3 different time slots and email it to support@nobigdata for hands-on. Okay. How prompt will be your response? Till Monday, I would reply in 6 hours. Otherwise, okay, till Monday because I've been traveling. So till Monday it will be 6 hours. Afterwards it will be faster. All right. Okay. I'll try to be quick. Okay. I'll try to be quick. And a question from Ravi. In real time, how does the files placed by machines are uploaded automatically in real time, as in real life? Okay. Quick answer is using Tune. We'll give you the demo. In case you want to go through quickly to that part, you can go to the session number 9 of this one, where we have given the demo of Flume, where the data in real time is getting pushed to HDFS. Okay. Okay. Any other questions? Ila, was he able to answer your question? Good. Okay. So this is my account. So here, if I go to my file browser, file browser, in case this file browser is not clickable to you, just type file browser in the URL. That should be. For some reason, this file browser is disappearing in Vue. Maybe they are fixed in the newer version, but I'm not sure. Okay, sure, Ella. Let me respond to you, and then we can have it, take it forward. Okay. You can call me in case you can call me on my India number 9538998962. That's my India number. Okay. So because that will be quicker in case you want a quick response, you can give me a call because I'm on the channel. All right. All right. Great. Now let's again a quick overview of how do we, right? At least repeat these steps, whatever we have told you. Okay. and go through this. There is no need to run MapReduce right now. We will run it afterwards. Okay. All right. So a quick question to all of you. And the question is, okay, so before we jump into MapReduce, I want to establish why do we need it in first place? Okay, by posing various kinds of questions to you and reach to a conclusion by the way of discussion. Okay, so the first question is, if you have a plain text file of all the Lord of the Rings book, say close to 50 MB, how would you find the frequencies of words? Okay, frequencies of the word means count of each unique word in the book. Okay, because Lord of the Rings book is huge, as in 50 MB. If you have to find frequencies of the words, of all of the words of Lord of the Rings, okay, meaning a word should be only counted once. Okay, it's a let's say this is something you is assigned to you as part of your office work. Take this 50 MB plain text file and give us the frequency of various unique words in this text file. Okay. Okay. Kulveer says by sorting and grouping. Any other thing? Consider it like your daily kind of assignment that you have to. Somebody has asked you to do this, and how would you get it done very quickly or in a very nice fashion? Feel free to pour in the ideas. The more varied the ideas, the better they're going to be. So feel free to pour in your ideas. Yeah. Okay. Ravi says by splitting and sorting. Okay. Next question. I'll just put bullet points on these. Any other? Good. So far, good. I would, Ravi and Priyatam, I would like to know which tools will you use for sorting and grouping or splitting, and yeah, okay. So yeah, so that was the question for Kulveer and Ravi. Priyatam's answer is quite straightforward. The answer is what Priyatam is suggesting is the only thing I know is to import to Excel and creating pivot table. Good, good. We'll just keep this as one of the answers. And okay. Katie is also suggesting sorting and counting. Okay. Ron is suggesting select count. Ravi is saying parse the text word by word. Good, good. And yes. Okay, let me take this text file to the side so that everybody can see the question again. Abru is saying break the big file into small chunks, assign it to different machines, and then sort and group. Brilliant, brilliant. You are just few steps ahead to us. Okay. Ashwini is saying splitting into substring and then counting. Brilliant. Ashwin is saying by creating threads for each thread, assign pages equally, and then our results combine. Good. It's few steps ahead. Okay. Ella is suggesting sort them into name value pairs and then go ahead. Okay. Okay, Yogesh is saying, can we? I'm not sure if we can use cell command in HTTPS. Yes. No, you can't use cell command in HTTPS. Right now, this we are not talking about HDFS. We are talking in general. We are talking in general. Alan is suggesting that if we are not using distributed computing, I would just pass through the file and use some sorted data structure to keep track of. Okay, this is a very good answer. This is a very good answer. Okay, so if we are not using distributed computing, I would just pass through the file and use some sorted data structure to keep track of counts in each file. Great. Sorted data structure means something on the lines of, say, hashmap, or maybe some kind of a heap, some kind of an array, or some other data structure. Brilliant. Okay. This exercise is very important for everyone because this essentially tells you that there is not a single way of doing things. There are many different ways of doing same thing. And that's very important when you grow into an architect's position or engineer, manager, senior and engineer. For every kind of position, these kind of questions are very important because these questions open you up for newer ideas. Okay, so pass the file, create the key value pair and the frequency. Good, good, good. So that's pretty much the answers of everyone. Now, this is something I'm going to take up one of the approaches suggested in. So this is kind of one approach suggested in the most of the answers. I'm calling it programmatic approach, whereby we create a frequency table, some kind of a sorted data structure, as Alan puts it. So we create, let's say, a frequency hash table or dictionary. What is a dictionary? Dictionary is a data structure where finding a particular key is very quick. The way you pick up a dictionary and you can quickly locate a word in the dictionary and quickly reach to the word which you are looking for, right? So a dictionary is some kind of a data structure in computing, say hash table or there could be many form of it. So we could create a dictionary which internally would have some kind of a data structure which makes it really quick to find a particular word in the memory. Okay, so we created this dictionary. Dictionary contains key and the value, means word and the answer, right? So the dictionary gives us an interface whereby we can insert key and the value, and we can retrieve the value based on the key. Okay, so we create an instance of a dictionary, then we go through the file end to end and keep checking the word in the dictionary. If it is found, then increase the count. The count is the value in the dictionary and the key is the actual word. And then in case it's not found, we create a key value in the dictionary and then insert 1 at the value. And then we keep on doing it till the end. So this is a programmatic approach. We can write code for it. Okay, so do you see any problems with this approach? Anyone? What are the various problems with this approach? Ravi is suggesting it's time consuming. Abru is suggesting time consuming. Ravi Khurdu is also saying time consuming. Interesting. It's the same phrase being used by all. Good. Okay. Now the LLM suggestion is the time will depend on linear scan through the file and then on the speed of search through the data structure. Good, good. So as the okay, so question, I mean the problem suggested by Katie is the volume of words is too high. Okay, yeah. So okay, go ahead. So when okay, let me ask you a quick question. Again, if you remember our discussion on the first day, in terms of memory, CPU, network, and the discrete speed, if we if this text file size keeps on increasing, let's say instead of Lord of the Rings, we get more text tomorrow. Let's say we have to do the word count of Wikipedia. We have to find the frequency of words of all the words existing on Wikipedia. Then, do you think this approach is right? If not, then which resource on your computer will become the bottleneck? Good. Yes, that's right. Vietnam and LN, that memory and RAM will be the first problem, and Ashwin also. Yes. So as the data grows bigger, the problem is when the data grows little bigger, RAM will become the bottleneck. So we cannot process the data which can't fit into the RAM, right? So what do you suggest? What alternatives do you suggest? And same problem is there in the other cases as well. The case which somebody suggested that we will use Excel for the same thing. Okay, we will use Excel for the same thing. That will also have a similar problem of sorting. Yeah. Yes, Ritika and Ravi, you have questions? Yeman is suggesting that split the file into smaller fixed file size. Yes, that's the right approach, and that's what we're going to talk in a little bit future. Yeah. Yes, Ravi, that's good. That's good. We will talk about it. So, can we right now? Can you suggest some other alternative? One suggestion from Yeman and Ravi is that let's chop the file into small words. But if you do that, again, we have to create a single hash table, right? Even if, let's say, we split the file into smaller chunks, same word could be in one first chunk and same word could be in second chunk. So we anyway have to swap the results. We anyway have to again do the same thing. Correct? Now, this second approach somebody suggested was I'll do that by using SQL. Okay, so that answer is good because most of the memory issues are very well handled by SQL. So we could do this way that we break this book into one word per line, then import this text file into a database, and then group the database, group the table, and count the words, right? So this approach avoids making the memory as the bottleneck, and because SQL takes care of sorting in the disk very well. Make sense to you? So although there are many, we could also do the same thing what SQL is doing. I'm just taking the example of real life, whereby if you have to do the same thing in real life, we will import the data into SQL, count it, and then that's it. By grouping. A third approach similar to the approach number two. Third approach similar to approach number two is by using Unix. Okay. By using Unix. Okay. We talked about the command prompt last time. So here, let me explain what does this command do. Okay. Let me explain what does this command do. Let's say this command. All right. We're here. Okay. This. Let me try to find an alternative way to paste. Okay, here is the command. Okay, let me dissect this command for those who are not very comfortable with Unix. Okay, so here we have cat file. Okay, so what we are trying to do, we are trying to first break a single line into one word per line. How? By replacing space with new line. Second, we sort or order the lines using the sort command. Then we find frequencies using unique, and then we scan. Okay, so we find the frequency using unique, and what does unique do? It scans from top to bottom, prints the count when the next line is different from the previous line. Okay, so let me also open console for you. Okay, let it open. Okay, so okay, let me just explain this and then we'll talk in detail. Okay, yeah, good. It came. Copy, paste, then again copy, paste. Good. Now this is my Linux console, or you can say terminal, whereby I'll execute my command and then I will see the output. Okay. The first command which we have is cat, my cat file name. So right now, let's say my list is my file name. Let me just take up this list. Okay. Or maybe I could take, say, do you see big.txt anywhere? Yeah, we have big.txt. So we could say cat big.txt. Now, if I say cat big.txt, it's going to overflow my screen. So what I do is I pipe the data of cat to another command called more. Okay, so more is one command here, and cat is another command along with this argument. This is the argument, as in this is the parameter which we are passing to cat, and cat will be printing the data to the screen. But since we are using a pipe here and then some command afterwards, so what it's going to do is instead of throwing the data to your screen, it's going to send the data to the command called more. Okay, so what does more do? You can see it's showing us the full data page wise. Okay, if we want to do a word count on this, okay, it's basically counting number of lines in this file and so on. The word count, the word count WC command would not be able to do what we are trying to do, because word count blindly counts characters and the number of words. It doesn't count number of unique words or how many times each word has occurred. So cat big.txt is the first thing which we are going to do, and then so that's why that this one is giving out my data. Then we are replacing space with new line. Okay, so this command is very important. Here it says as for substitute, space or tab any number of times. Okay, so replace space or tab. Whatever is in square bracket, this means tab, this means space. Okay, and square bracket means any of the things inside this box, and plus means any number of times. So any number of times space or tab needs to be replaced with new line. That's what this command does. Okay, now again, since this is also going to overflow my screen, I'm going to put more after this. Okay, this did not do much of a magic. Let me try to put 1 minus e. Now that works. Okay, let me in the slide itself, I'll also update here means minus e. Okay, so now what it did was very important thing. What it did was it broke every word, the whole line into such that there is only one word per line. All right, is the video and audio in sync now? All right, so it basically broke each line into one word per line. Now next step is what we're going to do is next part is sort. Okay, sort. First let me show you the sort command, or let me just do one more thing for you. Yeah, sort and then again more, because it's again going to overflow my screen. So okay, let's go, because there are too many spaces. So all those blank lines, empty lines have come forward, right? Okay, so let me just remove more and let it go. You can see this. All right. So here, what we have done is get printed the file onto the screen. Instead of screen, the data went to SED command. SED replaced space or tab with new line, and then sent the output after replacing space or tab with the new line. Sent the output to sort command, and sort command is something which is running right now here. It finished very quickly, and then it sent the output to another command called unique minus C. What unique minus C does is it finds the unique words in ordered data, sorted data. Unique minus C does not find the unique letters or unique words in the unsorted data. Okay, so that's a very important thing to remember. Hi everyone, are you able to hear me clearly? Okay. All right. So yes, I'll have to log in again. My terminal has ended. Yeah. Now, this is a very important aspect. You could say that the data which is being given by SED is being given to sort. And this sort command is having one more argument saying minus S1G. What does it mean is this sort command will not consume more memory than 1 gigabyte. That's the interesting aspect of sort. So what the suggestions which you have been giving, Yiming, Alan, and Prem, others as well, that split the data into parts. This sort command is doing that for you. It's sorting using only 1 gigabyte of memory. Minus S1G means use only 1 gigabyte of memory. Okay, so this one prints the data, this one converts the data into 1 word per line, and then this one sorts those words using only 1 gigabyte, and then this one would give us the unique words, right? In case, in case you want to convert everything into lowercase, you could also use something like this, something like this, okay? Something which means is it's going to replace capitals with small. Okay, put the pipe here. And okay, this is changing my single quote into something else, and I don't want to change. All right, here, this way. Okay, instead of my file, it is big.txt and so on. And then I can say more, right? And now here we'll be having, okay, let me just open this, copy, and all right. So you can see that this some word art is there. Now you can see. Now further, here the data is not sorted by the count. I'll have to. Now you can see, okay, so here the data is sorted by lexically. That means all those words which have 10 frequencies come together. All right, good. Just give me one more second. Yeah, all right. So we were able to, using this command, we were able to find all the unique words and we could further pipeline it. Okay. So basically, these two approaches, the last two, the SQL one and the Unix one, these two approaches would find the unique words in the file using limited amount of memory. So the problem of memory is well solved by approach number 3 and approach number 2. Correct? Is everybody with me on this? Great, great. So basically, this command, which I have made here, it helps us to, to do the word count using only 1 GB of memory. This is a very important command. This is a very important command. All right. Now, what exactly do you think is the problem with approach number 2 and approach number 3? Anyone? Okay. All right. So, okay, let me explain the command. So, question from Ashwin is, please explain the command. Which one you have added? Why is minus e used for? Okay, I'll explain. So here minus e means use the regular expressions in Linux. Okay, this SED command by default does not expect the regular expressions in the pattern. Okay, therefore, if you want regular expressions in the Linux SED, then you need to specify minus capital E. Okay, so first we printed the data, then piped it to say converted it from uppercase to lowercase, and then the full text stream is sent to SED, which replaced space or tab with new line, spaces or tabs with new line, and then sorted those lines by using sort command, and we put minus f1g means use only 1 GB of memory. Now, what happens when this data, which is coming from SED, when this data grows beyond 1 GB? Sort command internally splits the data. Sort command internally splits the data and then do the juggling. Okay, sort command internally splits the data and then merges the data by using a kind of a merge sort approach. Okay, I'll explain that approach because that's a very important approach part to how do we sort humongous data in case of memory constraint. Not because it's a great computer science concept, but because it's quite applicable when you try to understand matrix. Okay, so sort command, it won't throw an error when the data grows beyond 1 GB. Instead, it will split the data into 1 GB size, sort it, and then merge it. Okay, then merge it. All right. So that answers Ashwini's question, and Abru was able to answer your question. Priyatam says processor is the bottleneck. Lee, I did not get your answer. I think, okay. Ravi says, may become an issue when the file size become bigger. Say something like wiki, that's right. Now, question from Ashwin is, what does this TR-A-Z does? It basically converts the text in from uppercase to lowercase. Okay, translates capital A to Z to small a to Z. Okay, so a question from, yeah, that's right. So sort is probably doing it all in the memory, whereas SQL goes forth and back. But if you put sort minus capital 1 as 1 gig, then it also splits it into this, puts it into the disk in two parts, and then loads 1 GB only at a time, and then solves it. Okay, so so it does similar to what SQL does, goes back and forth to the disk. Ron suggests that this kind of approach might take a bit of longer time to run. Yes, that's right. What else do you think? What kind of problems do you see in the approaches as approach 2 and approach 3? Yeah, good. Good. So yes, CPU might become a bottleneck. That's a good answer. And all right, brilliant. Yes. So, so the moment, so the moment the data starts growing bigger, the data start growing bigger on what could fit into the RAM, the time taken starts increasing, because as the data starts growing bigger and bigger, what happens is more and more disk read and write starts happening. Okay, so disk speed, CPU, and disk space will become a big bottleneck. After a point of time, you may not be able to store used data into the same disk. Even if you do, you won't be able to read the data from the disk in the time that is allowed. I mean, in a reasonable amount of time. Okay, and then the CPU might become the bottleneck. All right, so so these are a few things we have to take. Okay. All right. So okay. Now, the next approach, what somebody has already suggested, some of you have already suggested this approach, approach number 4. We call it external sort. And you'll be amazed to know this. This is how we did things long back. And and the way, and there are actually quite limitations in this kind of approach. This is how we did the distributed computing of around, say, 6, 7, 8 years back. In this approach called external sort, what we do is we split the data, we split the file to a size that fits into the memory, say 1 gigabyte. And then whatever approaches we have used, like approach number 1, 2, or 3, to find frequencies, okay? So we use those approaches on individual machine. And then whatever is the result from machine 1 and machine 2, we merge it together. So the launcher, you as in you, the launcher sends slices of data to machine 1, machine 2, and maybe more machines, right? And these machines finds the frequencies, like here he was sent sa, re, re, and machine 1 returned re 2, sa 1, okay? While machine 2 returned ga 2 and re 1 based on ga, ga, re. Okay, now launcher will merge these two into one list. Okay, launcher will merge these two results into one single result and give this. Is this approach clear to you? So launcher is doing the heavy lifting. First, it slices the data into two parts. That's not a big deal, although you can basically find the number of lines and then keep on reading the data and keep on sending to both the sides. Machine 1, machine 2, machine 1, machine 2. Send one line to machine 1, send second line to machine 2, and so on. So launcher is sending the data into half to machine 1 and machine 2. The way people on a poker table, people distribute the cards. Okay, so launcher has divided the data into parts and sent it to machine 1 and machine 2, and then machine 1 and machine 2 has found the frequencies and returned to the launcher. Now launcher merges the result and gives the output. Now the important aspect is the results sent by machine 1 and machine 2 are ordered. You can see re is before sa and ga is before re. The output sent by machine 1 and machine 2 is ordered, so that the life of launcher becomes easier, right? Because machine 1 anyway has to sort the data to find the frequencies, and similarly machine 2 anyway has to sort the data to find the frequencies, and then launcher is merging them because it becomes easier to merge this sorted data rather than unsorted data. Okay? It's easier to merge the two data sets which are already sorted. All right? So, like I'll show you one good example. Let's say part 1, okay? Or you can say machine 1. I'll take an example of numbers instead of words because that's easier. Machine 1 is having these numbers. Okay, that's machine 1. Machine 1 is having these numbers. Okay, machine 2 is having so let me just show you that. So what is it that I'm trying to explain here is it's easier to merge the sorted data than unsorted data, right? It's easier to do that. I'll show you. Let's say machine 1 gave these words, machine 2 gave these words. Or let me just take some more examples. Okay, so you can see that The results of machine 1 are ordered. Similarly, results of machine 2 are ordered. Now, the launcher has to merge these two results together. It's quite easier. It's quite easier. You just stand in front of these two. You imagine that this one is a queue, and you're standing this side. You're standing this side, okay? Now you compare the two. You compare these two. Which one is smaller? One is smaller. So let's take one out. Okay. Then again compare the two. Which one is smaller? Two two is smaller. Now you can see that 3 and 4. 3 and 4. Good. And then again 4. You can see that. Now out of these two, who is smaller? 5 is smaller. And then 6. Okay. And then 9 to 12. So it's like during the assembly in the school, if you have merged two lines in which students are standing already in the increasing order of their heights, it's very easier to merge them. So it's easier to merge the sorted data than unsorted data. Okay, the objective is to merge two data sets so that and the results should be sorted. Sorted means ordered in some way. Okay, so basically you could just stand in front of the two queues and pick the one from the front, which is the shorter, and then keep on putting the shorter from the both the queues from the front into new fresh queue. And that's how launcher is also merging this result and this result. Launcher will check who is ahead, RE or GA. Will just pick GA and put it in the results. And then again compare RE and RE. If they both are equal, merge them as in sum of their frequencies and then remove them, and then only SA will be left. This is how launcher merges two sorted data. The important part here is that we have to only do the single pass. Okay, because it's a very straightforward process. Stand in front of line, we keep on picking the shorter one from the line, and then keep on putting them into a new queue. So therefore, merging a sorted data, merging ordered data is easier than merging unordered data. That's why machine 1 and machine 2 is returning ordered data. Did I make sense, everyone? Are you with me in this approach? So launcher send one piece to machine 1, another piece to machine 2. Both machine 1 and machine 2 gave the results, okay, to the launcher, and these results are ordered by the key, and then launcher merged them and gave the result. Okay. Any questions at this point? No questions? Everyone? So my question to all of you is, what is wrong with this approach? Here, CPU is no longer a bottleneck. RAM is no longer a bottleneck. What is it that's the bottleneck? Anyone? Yeah? Good. Lucas is suggesting the size of data. So what is wrong with this approach? Alan is saying that a lot of merges will take place. Yes, that's good. Ashwini is saying lot of network transmitting files over the network. Brilliant. Yes. Ravi is saying coordination between tasks could become the bottleneck. Brilliant. Just brilliant. Great. Yes. Lee is saying that keeping it all in sync is another problem. Yes. Brilliant. So yes. So few things we talked here, the suggestions which have come from you. One, network is going to be the bottleneck. And Alan is saying a lot of merge is going to be taking place and it's going to be the headache, yes. And coordination is required and synchronization is required. Okay? Yes. Anything else? Okay. So So the problem with external sort is time is consumed in the transport of data, as you have suggested, and then for each requirement, we need to write a special purpose network-oriented program, meaning we would require a lot of engineering in terms of, in case what happens when machine 1 fails, machine 2 fails, what happens in case of the network fails, and so on. There are many, many problems. So two suggestions. I mean, two main problems. One, lot of time has gone into transport of the data. Every time we need to churn the data, we need to push the data to all the nodes. But in case of HDFS, the data is already distributed. Map discuss further can eliminate that problem. Second, a lot of engineering is required in this case, and therefore a paradigm like MapReduce makes the life easier, where we have to only write a function called map, which will tell what is the criteria of sorting, and reduce, the second piece of code which we have to give to MapReduce, and that would tell on what basis launcher will be merging the data. Okay, so MapReduce is little better than this. MapReduce is little better than this. First, there is no network transport, or there is only minimal network transport happening in MapReduce. Second, we do not have to do a lot of engineering, and we do not have to build special purpose programs. All we have to write is map and reduce. Good. Um, Okay, so I have a quick some change of plans. So I'll have to announce it quickly. Today's session would, I'm sorry to write it in capitals, would end at 10 p.m. IST. That is 15 minutes from now. Okay, so I have I've got something urgent that has come up. So today's session will be only 2 hours long, and we will continue tomorrow. So we have just 13 minutes. So if you have questions, you can ask now, or I can continue with my discussion. Okay? Yeah, you have a question for me, please. Go ahead. All right. Now, a brief introduction about Yes, Ritika and Yeman, you have a question for me. You have raised the hand. So, question from Priyatam is, will you be demonstrating real examples of MapReduce later in the course? Yes, we will be demonstrating tomorrow. Okay, we'll be demonstrating the, okay. And in case you want to go ahead, you can just look at the session 3, session 4, and there are quite a few examples. Take a look. All right, now here we are. So, what exactly is MapReduce? It's a programming paradigm. The way you write select star from table, similarly, or when you are writing a grouping statement, it's similar to a programming, the way SQL is a programming paradigm. In a similar way, MapReduce is a programming paradigm. It helps solve big data problems. And it's not only limited to Hadoop, it's also used in similar ideas are used in Spark, similar ideas are used in Cassandra, and similar ideas are used in MongoDB and Couch. Okay, so it generally to solve use data related problems, specifically those kind of problems where where sorting is a very important work. Okay, sorting is a very important work because MapReduce as an infrastructure, the underneath platform, what it has done is it has made sorting distributed. It has made sorting distributed such that one part is being sorted by one machine, second part is being ordered by another machine, and third part is being ordered by some other machine. Then somebody is merging all of that. Okay, so it's specifically for the sorting intensive jobs. Okay, and sometimes even if there is no sorting required, you only need to clean up the data. In those cases also, it's quite useful. Specifically, the data is so huge, the data reading is going to take huge time. Specifically, if the data is beyond 15 gigabyte, because 15 gigabyte is the time when you start realizing the data read also takes time. 15 gigabyte means 75 seconds. Okay, because it takes around 5 seconds on a very fast hard drive to read 1 gigabyte. So 15 gigabyte means 15 into 5 seconds, that's 75 seconds to read data from hard drives. And that's when you start realizing maybe we could get it distributed and done using multiple machines. So sorting intensive huge data problems, that's where it's used. All you have to do is write a program called map, which will convert the input data into key and value. Why? Because it wants a criteria on which it would sort the data. If you give no criteria, it won't sort the data. It won't sort the data. Then it wants a criteria to merge all the values together for each key. In case you don't have a reducer, don't worry. In case you have, in Mapper, you are not doing anything, that's also fine. So, all right, it's supported by many systems. Now, in the MapReduce can be written in many ways. Okay, so if you are not from Java background, do not worry. We can write any shell script. We can write MapReduce using the existing any Python, Perl, PHP, and shell script, Java, or any binary for that matter. We can write MapReduce using those. All right. So that's a brief theory about MapReduce. I'll try to give you an example of word count. Okay. So imagine that you have to give out key value pairs, right? And your pseudocode would look like this. This is a pseudocode of mapper for word count problem. So this is a very common problem where we try to do the word count, unique word count. Okay. So we write a function called map and we write a function called reduce. And when we are done, we hand over the two functions to Hadoop along with the file which we want to process. So we have a file that we want to process, and we have a program called map, and we have a program called reduce. We hand over these two to the Hadoop. Okay. So input data is given to this function, whatever you have written, and this function of yours is going to be run on all the machines in order to extract key and values by Hadoop. And once Hadoop receives key and values from Hadoop receives key and value from your program, it's going to translate it into, it's going to order it, and then group the data. Okay, now let me take a step back again. So you have written two functions. One is called mapper, other is called reducer. What does mapper do? What does your function called map do? Does it goes through every word in the input. So map receives input line or input text, and then map goes through each and every word of that input and creates word comma one. Here you could have any other thing. Here you could have any other structure. Okay, this is your code which will convert an input to key and value. The way when we write SQL and we are writing a group by, we tell, right? We tell that select star from a table, group by this particular column. Similarly, on whatever basis you want the data to be grouped together, you say that key. And whatever data you want to be grouped together, let you put it in the value. So the basis on which you want to group a data together, you put it in the word, and the value remains that way. In case you don't want any reducer, you can have no reducer at all. Okay, which means sorting wouldn't happen. And whatever is the output of mapper will be saved in the output. Okay, goes to the output. All right. So this function of yours converted the input text into key value like this, and then Hadoop did the magic from here till there. This magic is being done by Hadoop for you. Okay, this magic is being done by Hadoop for you, and then once it has grouped the data together, then for each of the keys, your reduce function is being called. For each of the input line, your map function is being called. For each of the key, the reduce function is being called, and all the key and the values are being passed to your reduce function, and this reduce function is just returning a count. Okay, it's just returning the sum of all the frequencies, and that's it. That here we have the word count. Okay, so you did not have to do sorting. You did not have to do reading of the data. All you have to do is specify the key behind a key on the basis of which the data has to be sorted, and what data has to be sorted that goes into the value. Okay. A question from Ravi is, what happens if I have a major number in my file? This I did not get. Could you explain? As in line numbers in your file? All right. Yeah, I'm trying to understand the questions. What happens if I have a measure slash number in my file? Okay. So instead of value, I'm trying to understand. Okay. So here you could basically, in this piece of code, if there is some words you want to skip or some data is invalid, you can write that logic here by putting any condition and then saying if the word is among this and that, don't print it in the output. Okay. A question from Ashwin is, in this example, there are key value as in sa and 1, which is repeated. Yes. In the key value pair, it doesn't happen. Okay. So here you can see that. So Ashwin is saying that in generally key value pair, it doesn't happen. It does happen. Okay. Because see, you're going through the text file and printing key value. The there are high chances the key value could get repeated unless the data itself says that it will not get repeated. That means you do not need uh, you do not basically need sorting. Your data is already sorted, or yeah. In that case, you cannot do the counting, right? Because every word is occurring only once. All right. So this is the first example. Is this example clear? So you wrote a function called mapper, which converts the full text into key values. So here it's 1, not L. Okay. And then you wrote another function called reduce. These are pseudo code. We'll go into the actual code later. Reduce function reduce. It takes two arguments called word and frequency. Argument as in parameters, and then it returns array dot sum of frequency array. This is the array of integers, and then it does the counting. All right. So that's pretty much for today, and we will continue from this slide tomorrow. Okay. If you have any questions, please send it to me. I'll try to answer it. Drop it at support at no big data, and I'll try to answer it. Okay. All right. So all right. So so we'll continue from slide number 16 tomorrow at the same time, our usual time. All right. Are you able to hear me? Yeah. All right. Bye bye. Have a good day.